Every drop of water in your body is older than the sun. That's not a metaphor. It's a fact scientists can actually prove. And the proof involves asteroids, comets, and a 4 billion-year-old cosmic delivery system. Here's what we know about early Earth. When our planet first formed, about 4.5 billion years ago, it was nothing like it is today. Imagine a ball of rock so hot it was mostly liquid, constantly bombarded by asteroids, covered in volcanoes, with no oceans, rivers, or rain. Any water that existed would have instantly turned to steam and drifted off into space. The early Earth was dry, completely dry. So where did all the water come from? First, let's understand how water exists outside our planet, even today. You'd tend to think water is something unique to our planet, or at least something rare. But it's actually one of the most common things in the universe. Giant clouds of it drift between star systems. It's been found on comets, on asteroids, on moons of other planets. So water didn't come from Earth. It was out there long before Earth even existed, which means it had to travel here. About 3.9 billion years ago, Earth went through something extraordinary. The early solar system was still full of leftover rocks and asteroids. For a period that lasted millions of years, those rocks rained down on Earth in massive numbers. Think of it like a cosmic storm of asteroid impacts, one after another. Many of those asteroids weren't just plain rock. They had water locked inside them, frozen deep in their minerals, like moisture trapped inside a sponge. When they hit Earth, the heat and pressure of impact released that water. Slowly, over millions of years and billions of impacts, it accumulated. Much of today's water is thought to be the result of that process. But how do we actually know it was asteroids and not something else? Like comets. Comets are basically giant balls of ice and rock flying through space. So they were the obvious suspect for a long time. But the answer isn't so obvious. What's your guess? Comment asteroid or comet below. Here's how scientists figured it out. Water isn't all the same. Depending on where it forms in the universe, it has slightly different properties, like different versions of the same recipe. Scientists can measure those differences in a lab and use them to trace where a sample of water originally came from. Think of it as a fingerprint, invisible to the eye, but unmistakable under the right instruments. When they tested Earth's water against water from most comets, the fingerprints were a clear mismatch. When they tested it against water from certain rocky, water-rich asteroids, the fingerprints lined up far more closely. And here's something that might surprise you. Even today, Earth isn't completely sealed off from space. Every day, roughly 100 tons of cosmic dust, leftover fragments of asteroids and comets, enter our atmosphere. Some of it carries traces of water. And if you've ever seen a shooting star, you've actually watched this happen. That flash of light is one of these particles burning up as it hits our atmosphere. So in some ways, water still travels to and from our planet in space, just not as dramatically or chaotically as it did billions of years ago. The sun plays a role in this too, and this is where it connects to the moon. The sun constantly sends out a stream of tiny particles in all directions, a kind of invisible wind that travels across the entire solar system and hits everything in its path. On Earth, most of that solar wind never reaches the ground, but on the moon, which has no atmosphere and no global magnetic shield, those particles strike the surface directly, and when they do, they can react with materials in the lunar soil to form water. It's one of the reasons scientists weren't completely surprised when water was confirmed on the moon. Space doesn't deliver things to one place and ignore everything nearby. So is Earth's water permanent? Are the oceans here to stay? For now, yes. The water we have has been here for billions of years and isn't going anywhere anytime soon. But here's the long view. The sun is slowly getting hotter over time. Not in a way you'd notice in a lifetime, or even in thousands of generations, but over billions of years, it adds up. In about 1 to 2 billion years, the sun will be hot enough that Earth's surface temperatures start to push beyond what liquid water can handle. The oceans would slowly begin to evaporate. And once water turns to vapor high in the atmosphere, it breaks apart and drifts off into space piece by piece. Some scientists even think we might end up looking something like Venus, the planet closest to us, similar in size to Earth, and which many believe once had oceans of its own. Today, it's a dry, scorched world where the surface is hot enough to melt lead. No water, No life, just rock and heat. That could be our future, just not our near future. So here's the full picture. The water our bodies carry has been on an unimaginable journey. It formed in space. It traveled here on a rock. It survived billions of years of Earth's history, oceans, ice ages, rain cycles, rivers, and now we can drink it. That's not nothing.